Hey guys, Sensei Brad here, and today I wanted to talk about my new programming language called Dragon. Why create Dragon? I wanted to create a programming language focused on building programming languages through the power of metaprogramming. I also just, through my own research, wanted to prove that programming languages don't have to be multi-million line codes, multi-million line programs, kind of like GCC, and they can be done in the tens of thousands of lines, which is much simpler and any somewhat experienced developer could probably do. I also wanted to make compiler design simple to understand because there's a lot of things like Flex and Yak and Antler that make people think that they need all these external tools in order to create a compiler, when I think in reality you only need one programming language to really do so. Just normal everyday code. And it's also just my dream. So what can you do with Dragon? Dragon can do fundamental operations like any other programming language can. So it has structures, functions, math operations, other basic like binary operations, file operations, stuff like that. But what I think that separates Dragon from other programming languages is the ability to compile with Dragon code, compile, run, and retrieve results from code all during runtime. In other words, a Dragon program compiling another Dragon program, running that Dragon program, and getting results from that Dragon program using Dragon. Kind of crazy, but it allows you to do things like you can write a build script without having to use another language, for instance, Makefile. So what I mean by that is because what you can do is you can load the files using Dragon like a normal programming language. You just load the files into a buffer. You send that buffer to the compile instruction. The interpreter compiles, the compiler part of the interpreter will send that data back to you, and you'll be able to debug and run the code. So, for instance, one thing that this also enables is that you can actually use code to debug other code, which I don't think is something that you see very often. You can also create code based on an external blueprint like JSON and use it. What I mean by that is if you want to generate a parser, but you didn't want to write it all by hand, or it's like really, really complicated, what you could do is you could take a JSON file, write your syntax however you want to organize it in that file, and then write a Dragon program that generates more Dragon code as a parser, or generates a parser in Dragon. But what can't you do with Dragon? I understand some of these are deal breakers, but for now, here's what Dragon can't do. Object-oriented programming, fight me, that's not coming. Access the internet for security reasons, and calling interpreter external functions. For instance, you can't call a DLL or an SO without modding Dragon itself. That's mainly so that the programming language remains consistent, because if people could just add DLLs in their own instructions, it would be way too crazy and things wouldn't work as well with each other. And also it's just a security issue. And what else that I haven't mentioned separates Dragon from other languages? There'll be more stuff in the future, but here are a few things before we dive into some code. The Dragon call and name scope, we'll get to those. Built-in program metadata that can be accessed during runtime. So in other words, in the Dragon binary code, there is JSON inserted into the data section that you can read and parse, and it'll tell you things about the structure of the program. And the same thing for the compiler. The compiler also has the ability to print out, to export JSON based on the compiled code that you gave it, or the uncompiled code that you gave it that it was compiling. There are no expressions. Yeah, I know I know that for some people that's a deal breaker. Yes, it can still do math, don't worry. But all statements are either a Dragon call, an offset, or a name scope. Basically what that means is that any math is done through function calls and not expressions. There is also no order to functions or structures. Any order will work across any files as long as the files have been added to the build. Then it will work. And files are simply added to the build by basically just appending the file itself to the compiler command. No weird package managers, just load the files and it compiles. I did not intend to rhyme. And I think one thing that really steps it apart from most languages, as far as I know, I'm the only one with an AI-generated theme song. Sue me. So let's dive into some code. Alrighty, so for the code showing portion of this video, what I want to do is I'm going to show you a basic hello world program, this guy right here, and then I'm going to show you just the proof of concept that you can in fact compile code with code. You can in fact compile, run, and get results back from code on the fly. So starting with just a little bit of basic syntax, we're not going to dive into it too much, but just a brief overview to get a vague idea of how it works. The dragon call is basically a function call, and it's a name, a set of 0 or more input arguments, and a set of 0 or more output arguments. It's that simple. And this is a function declaration, as hence the equal sign and the scope attached to it. And this dragon.main is always the entry point. It's like the main function in C. There's no arguments to it, but we won't worry about that right now. And what we're doing here, the first line of code, line 3, is we're taking a string and we're setting it as a buffer to this variable called message. And then we simply print this buffer as a string. And I won't go into buffers right now, but what I will do is I will show you just a basic compiler command. So for Dragon. So the Dragon compiler command is really simple. It's just a Dragon, you put the name of the executable wherever, optionally pass debug information. We're going to actually disable that. And the names of the files that you want to include. And starting with test all.dragon, as you can see there, what this file does is it has two different tests, elf and elf test, which is for Linux binaries, but we're not going to worry about that one. What we're going to worry about is the test.json. And the idea is that we'll be able to compile JSON code and read it in Dragon code. And as you can see here, we've got the names of the tests. These are all the file paths. These are the loadings of the files. And these are setting up the lists that all the files are a part of. And then we have this function called tools.justRun. Now, what this is the whole bread and butter of what I've been talking about. Tools.justRun is an example program on how to compile and run code with Dragon. And skipping these lines, it's really simple. All you have to do to compile Dragon code is, well, 1, it needs to be in a buffer. 2, you need to call the compile command with the sources buffer. 3, you need to determine whether there's debug information printing and whether you generate a Kickstarter. Don't worry about what that is. And finally, it generates bytecode and some error information along with some debug information. And this is just a simple name scope. We won't dive too much into it, but basically this is the name of the scope as denoted by the @ symbol. And then this is just a variable. If it's 0 or false, it won't run. Any other value is considered true and it will run. If it's not zero. And in order to run Anvil Dragon code, I call it Anvil binary code, is you need to open what's called a context. A context is basically just a big buffer of registers like you have in assembly. It's loosely based around that. And all you gotta do is just run this run instruction called context.install_program, which takes the bytecode, installs it in the context, and then all you gotta do is just determine how many instructions you want to run, which -1 in this case means runs until you're out of instructions, and then you just call the context with dragon.context.run. And it's that simple. Now to just see it in action, what we're going to do is we're going to clear this, and then we're going to show you, here's our compile command is used by makefile, and here's our test.json. This is just, I probably should show you the file that this is from. This is hello world.dragon. This is the first test. This is the main file of the first test. And as you can see, it's simply a couple of prints, and then here I'm testing the JSON compiler, which I'll probably get to in a second, and then just other stuff related to it. Don't worry about the rest of this code. It's not really that important. But what is important is this file right here, the read.json.dragon file. What this does is this takes a buffer of text written in JSON, and it compiles it into something that you can read. I haven't gotten the reading part of it done, but I do have the lexing and the parsing done at the time of this video. And to show off the basics of how it works without diving into code, as you can see here is our JSON. It's just a file that we loaded into the program. And then if you'll notice, it's got this number, a number, and a value. And there's a little more information to it than that. There are some positional information and debug information in it, but all you need to really know is that this is the type of lexeme you have, or token, whichever one you want to call it. I call them lexlings, so if you see that, don't be confused. They're lexemes or tokens, and what it actually sort of represents. And you'll notice that it's like the first opening bracket, the string, the colon, the string, comma, string, colon, integer, etc., etc. And it will lex this file, and then it doesn't show off the parsing mid parse, but here is a rough parse tree of what you have. You have the root, you have data and its value, oof and its value. I know these are weird names. Foop and its value, ofo and its value, foopo, of, hello, thing, doer, etc., etc. And the whole point of me showing you this is I just wanted to prove to you that it's totally possible to compile code, run, and get results back from code that in the same programming language. You don't need a separate file format or separate language like Makefile. It's possible to do it all in one language. And for now, that's where I'm going to leave the video. So thanks, guys, for watching. Feel free to leave a comment. And yeah, have a good one.